Hey everyone, so welcome back to Algorithm. Now I'm going to solve a bunch of random graphs question. Um, so a little fair warning about me that I do know graphs a little bit, but I suck at it. Right, I'm absolutely horrible at it. If that's a thing, right? So what I'm gonna try to do is get better. Uh, so right now I'm gonna do sheets. I'm basically gonna do Striver's DSA sheet, right? Yeah, so I'm gonna do A to Z sheet. Go here. Oh, I didn't realize I was this. Yes. Okay, so let's just start with problems on BFS DFS. A lot of things to do actually, if you look at it. So number of provinces, um, already done. Root orange is done. Petfill algorithm done. A lot of things already over here. So yeah, I mean, I don't think I've done hard questions. Oh, bipartite graph. This is something I wouldn't know. I'm pretty sure I would not be able to do this. Hmm. This toposort, this MST, and there are some other algorithms. A lot of things to do. Yeah. Okay, let's get started. Let's do one by one thing at a time, and go haywalk. Right. So go into number of provinces. Let's start it. There are n cities. Some of them are connected with, while some are not. The city A is directly connected to city B. City is connected to city C. Okay, a province is a group of directly or indirectly connected cities, and no other cities outside the group. You're given n into n matrix is connected, where is connected IFJs. Okay, so you're given adjacency matrix. Okay, return the total number of provinces. You just have to return the number of components, right? So this is just finding out number of components. Um, that being said, now if you remember, this is connected as an adjacency matrix. So what we need to do is either do a for loop 2D array thing, or then convert it into adjacency list and do it. I would prefer direct looping. So let's get started. For row is connected, and then you do for calls. Center of row. Right. Um. So we'll just keep going one by one, and what we're gonna do is, okay, so keep going one by one and then do a DFS if you get any component. Okay, now if so, no, pardon me. For row and range n, and range of n, then you do row number and then column, right, is equal to 1, then do DFS and mark the things as visited, right, where you have your row and column. So you give your row, you give your column, and then what do you do? Okay, so you have a direction where you have 1 minus 1. Okay, dx would have 1 and then 0 minus 1 and then 0, and then dy would have 0 comma 1 0 comma minus 1, right? So this will essentially either make it go up, down, left, right. Okay, or even better way to actually represent this is using this, where you say 0 minus 1 and then minus 1 comma 0 and then 1 comma 0, then you do for direction and direction, and I mean after this what you're gonna do is let's just take x comma y is equal to direction, right, and then yeah, you got the x and y. Now we have to check if x is less than 0 or y is less than 0 or x is greater than n or y is greater than n. In fact will be greater than equal to n, because you're doing 0 index matrix. Now if that's the case, then you just continue it, right? If it's not the case, however, you do the following. You make the is connected as true. You know what, I think this might be wrong, so let's take a step back and delete this. this is a great realization that I do not know how to do DFS for the adjacency matrix. No, well, that's a shame. I think I can probably learn first and then also answer. Um, let's try to do it on our own, right? Like, so this is your 0, 0, 0, your 1, 0, 0. So this would imply that 1 is connected to 0 and even 2 is connected to 0, right? Entire row is a node. Okay, so that's one thing. Let's say if I wanted to DFS from this part, right? Let's say we got this. How do I traverse? Now if you think about it, I am right now at 2, 0, right? And I know this is kind of true. So what I need to do is find everything that's connected to row 2. So what is connected to row 2? Only and only 0. So by then this will become 1 and 1. Yeah. So since I'm connected to row 0, I can say that 0 is here. Then I have to also say 0, 2. Right. And actually I'll see, I got this, and then I'll actually see the entire row first. What if there was another one and I was connected to 4, right? What if there was another node after all? Right? So I can either go to 0 or either you can go to 4, right? So that means I have 4 over here, 2, and then 0, and this is connected to 1. This is how the graph would look like. Right now I'm at 2. I can either go to 4 or I can either go to 0, right? So now if you look at it, if I'm at 2, how do I find out where I can go, right? So you have a bunch of questions to answer yourself. How do I find out this node is connected to which other nodes? Simply put, you would realize it's 4 and 0, right? But how? So you take row 2, or at least my hypothesis is take row n, run a loop, get the ones, the list you create, is your node's connection. Simple as that, right? So I take, now do a dry run. I take row 2, I run the loop, I get 0, 3. That is 0 plus 1 and 3 plus 1 node is connected. Zeroth first node and 0th fourth node, right? So that's fourth node and first node is connected. Okay, now you have the connections, right? What's next? How do I know which one is not visited? Right, in your normal recursion DFS you would obviously know that. Again, put a visited array. If row visited, mark it visited. So the 2 would be marked as true, right? So it will become visited equals to false, right? Into n. There you go. Okay. Now, how do I traverse? Is the last question. You got your ones. I mean, you got to know, like, you know, where to go and where not to go, right? Well, according to me, create a function like that, and you have to pass the row number, right? So that's basically a node, right? Now what happens? What should this DFS function do? Find the new neighbors of the nodes, loop through those neighbors, right? And do DFS if not visited. That's about it. I think yeah, this is it, right? I mean, I would hope so. I really would hope so. Yeah, let's give it a try. I already know what to do. Definition of DFS, put up a node here, right? Yeah, you can put visited of node is equal to true, right? And I have to extract the neighbors, right? So neighbors are a list, of course. Then what do is I run neighbor in connected of node, and then what I do should be pretty much very simple, right? What I'm gonna do is if is connected if neighbor is equal to 1, um, enumerate, yeah, okay, if neighbor is 1 and visited of I is also true, sorry, not visited of I, then yeah, you can do DFS of neighbor, that is a node in itself, and that should do the magic. So let's see, let's do it right and right. There's n length of connected for I. And it's with the row. I think you know what, we don't even need this, right? Because we don't need the columns and the rows, because every single row is a node. So you don't need to find which one is one, which one is not. Just do this. I think this is more than enough. Only thing that you'll have to make sure is not get the same thing going. If visitor pro, then don't do it, and yeah, I think this is good enough. And if length is connected, visitor folds of n, and then you do row 1 2 3 whatever, right? Like you start with this, for example, right? Is it visited? No. Put up a TFS, put as in no. Now it's visited. Now you're visited. This will become. That's true, right? Now what this does is it's connected of node, so that your node is true. This entire thing goes into a single array. Now neighbors are nothing but that. Now you do enumerate of neighbors, so you have your index and neighbor. If your neighbor is equal to 1, right, and your index is, that's not visited, so yeah, you put 0, right? This would be visited. Is this not visited? This one not visited. Yeah, it's not. Put up a TFS, go here. Okay, is 0 visited? Yes. So it skips that. It keeps going and going, right? So it skips everything. And yeah, this will pretty much do the job. What I can convert. Oops. Okay, wait. It's asking. Oh, my bad. It's asking the number of components. So, ooh. Okay. I mean, if we just put, components is equal to 0 and components plus equals to 1, and then we return component. That should probably do it. Ah, nice. That took a lot of time than expected. That's probably because I forgot how to actually do DFS with adjacency metrics. Um, so yeah, maybe this wouldn't pass. Yeah. Wait, is the visited not working? DFS of row component 1 visitor node is true. Yeah, this should go. Why is this not working? I mean, let's see. You put 1 0 0 1 0 1 1 0 0 1 1 1 0 1 1. You put up a node, you go there. And you put DFS of neighbor. Now if your neighbor is not visitor, it keeps going, that's all. I don't think there's anything to it. I mean, and this connected, this is this. You have your neighbor connected. Oh my god, unreal. Yep. Oh my god. That's such a stupid mistake. Oh my god. Amazing. Let's go. Okay, so, well, that's one question. Horribly done. I would say rather pathetic, to say the least. That's okay. I think we'll improve over time. So now you have your rotten oranges. The time is